Okay, for this next part, we will do two more examples that are slightly more involved than the first two, which just makes them a little bit more fun. Okay, let's say that we have 6y minus 4z equals negative 2, and 4y plus 6z equals 42. First thing I want to check is, are both equations in standard form? Yes, they're both in standard form because all my variables are on the left-hand side of the equal sign, and all my numbers are on the right-hand side of the equal sign. Now, if I just add them together right now, will I get any variables canceling? No, I won't. Is there something I can multiply one of the equations by and then get things to cancel? Well, I could multiply the bottom equation by 2/3, but that gets really messy. I don't want to deal with fractions if I don't have to. So what could I do? Okay, think about it for a minute. I really do want you to think through this. Let's say that I'm trying to get the z's to cancel. Well, if we think about it, to get the z's to cancel, if I multiplied the top equation by 6 and the bottom equation by 4, then I'd get negative 24z on the top and positive 24z on the bottom. That would work. Now I just am going to stretch you a little bit further. How would I get the y's to cancel? I want to give you an example of getting something to cancel where the signs are the same. Okay, I could use 4 and 6 again, and there's nothing wrong with that, but let me try to make my numbers a little bit smaller. If we look at the y's, think common denominator. What would the least common multiple of 6 and 4 be? What's the smallest number that they both go into? Well, 6 and 4, they both go into 12. So let's try to get a 12y and a negative 12y. To get a 12y on the top, I'd multiply by 2. To get a negative 12y on the bottom, I'd multiply by negative 3. Again, there are a lot of right ways to do this problem. I'm just choosing one of the right ways. So if we multiply the top equation by 2 and the bottom equation by negative 3, so I'm multiplying both equations by something, my y's will cancel. I need to make sure that I do it on both sides of the equation, not just on one side. So I take the top equation by 2 and the bottom equation by negative 3 and distribute that through. So the top equation becomes 12y minus 8z equals negative 4. And my bottom equation becomes negative 12y, because I'm multiplying by negative 3, minus 18z minus 126. So when I add these together, my y's will cancel, and I'll have negative 26z equals negative 130. Now to solve for z, I'll divide both sides by negative 26, so z is equal to 5. Turned out to not be so bad, even with big numbers. Okay, so to find y, I go and I plug it back into either equation, it doesn't matter. 6y minus 20 equals negative 2, add 20 to both sides. 6y equals 18. Divide both sides by 6, and we get y equals 3. So my point would be 3 for y and 5 for z. Now notice I don't have an x and a y, I had a y and a z. You don't need to list them as an ordered pair. It's fine if you just write y equals 3 and circle it, and z equals 5 and circle it. But if you do want to write it as an ordered pair, just list the variables in alphabetical order. So I'd put y first, and z would come second. To check my answer, plug it in my original equations, the ones that are typed in the homework or typed in the book. And the first one works, and the second one works. So my answer checks. All right, let's do one more problem. We have 6c minus 2d equals negative 2, and 5c equals 17 minus 3d. What do you notice about this one that's a little bit different? Okay, this one, the second equation is not in standard form. I've got to have everything in standard form before I start. So put this one in standard form, add 3d to both sides. Now I want you to pause the video and do this one on your own. Okay, now that you're back, let's look at the variables. We could either try to get the c's to cancel or the d's to cancel. Neither one of them is going to cancel right off the bat. And for either one, we're still going to have to multiply both equations. So let's just kind of anticipate what we'd have to do. If we wanted to get the c's to cancel, I'd multiply the top equation by 5 and the bottom equation by -6. That would give me 30c on the top and -30c on the bottom. If I wanted to get the d's to cancel, again, kind of think common denominator. I'd want both of those to turn into a 6d, and a -6d. So I'd multiply the top by 3 and the bottom by 2. Either course of action is totally fine. So let's multiply the top equation by 3 and the bottom equation by 2. The reason I chose that is that those d's are already different in sign, so I'm just going to capitalize on that, and the numbers are smaller. But it would have been totally fine to do it the other way. So if I multiply the top equation by 3 and the bottom by 2, the first one becomes 18c minus 6d equals -6, and the bottom equation becomes 10c plus 6d equals 34. Now, did my preparation work? Yes, it did, because if I look at those d's, they are going to cancel. So I add them together and get 28c equals 28. Just a side note, if you look at it and you don't have a variable that's going to cancel, don't add them together anyway. That won't help you at all. Okay, so we have 28c equals 28. Divide by 28 and I get c equals 1. Plug it back into either equation, it does not matter which one, and I'll get d is equal to 4. So my answer would be 1 for c and 4 for d. Plug it into my original equations, and they both work. 6 minus 8 is -2, and 5 is equal to 17 minus 12. Okay, those are the end of kind of our medium examples. Now we'll do some where we might have a different outcome happening.